so let's look at 4.7. If you look at the assignment on the board, that's going to actually be, that 4.7 assignment will actually be due Monday. And we're going to, that 4.8, I'm going to scoot it to next week and move some things around so that we don't have to, anyway, this is not for those of you listening on video in another year. This is for 2015. Okay, so let's start with just looking at problems like number 1, so you kind of know how to do that. All right, number 1 says, ooh, that's a very red thing here. Arc sine of 1/2. Now, when you see arc sine, what this is this is telling you that you're trying to find the angle. We've been solving for different trig functions. Now we got the ratio of the sides. That we most of the time we've been finding the ratio of the sides, right? We've been saying, what's the sine of 30 degrees? And we would say the sine of 30 degrees is 1/2. We could draw our little 30, 60, 90 and figure it all out, right? Now we're getting the 1/2 and they're asking us what's the angle. So this is code word for what's the angle. Another way to write this, and this is the way it would look on your calculator, is sine. This is the inverse sine. It's not sine to the -1 power. It's not 1 over sine, so you got to be careful that you don't get that confused. This is not the same thing as cosecant, which is the reciprocal function of sine, right? This is saying the angle who has a sine value of 1/2. So you read that, the angle who has a sine value, the angle I'll put which since it's not a person, has a sine value of 1/2. Now, if we have our a lot of our stuff kind of memorized, we might know that this is 30 degrees, or it has a reference angle of 30 degrees. The instructions here say find the exact value of each expression without using a calculator. So we pretty much know it's either going to be 30, 60, 90, 45, 45, 90, or one of those multiples of 90 like pi halves pi, 3/2 pi, 2 pi, 0, things like that, right? Because that's, if they don't want us to use our calculator, we're limited to that. So if you kind of keep that in mind, that can give you some hints on maybe where you should start looking here. I know that there's no 1/2s that come out of 44, 45, 45, 90, so maybe I go draw a 30, 60, 90 and label it. So we're still doing the same things. We're just going to look for a different thing, not the side ratios, but which angle has that side ratio. So let's see, across from the 30, I label it x. Across from the 60, I label it what?
X squared.
And across from the 90, we label it 2x, okay? So if I'm thinking about sine, that I might want to write SOHCAHTOA down. Those are some things that you can do to kind of jog your memory, because I know if you're like me, memorizing stuff is not so easy, but if you can kind of think, well, what tools do I have, maybe you can figure out what's going on here. Sine is opposite over hypotenuse. I want to have an opposite over hypotenuse of 1/2. And I see that I got the 2 on the hypotenuse, so that's good. Which, remember the x's always cancel out on these things, right? So which angle, 30 or 60, when you go opposite, would have a 1 as a coefficient? The x, yeah, that's a 1x. That's across, remember, we want the opposite angle, so, you know, the opposite of 1x would be 30 degrees. We're talking about a 30-degree angle here, if we didn't already know that. That's how you're going to do these. They're going to give you ratios. The big things that are going to be hard, we'll do some of those in a minute. The things that get hard on this is when they've done the rationalizing of the denominator, and you kind of have to unrationalize it in your head to figure out where those coefficients on the triangle were. So this is the A on that one of those where you have to kind of think about unrationalizing it to figure out what angle you're talking about. B is the arc sine of 0. So what angle, the sine of some angle, I'll call it x, has a sine value of 0? Where would I go for this one? What should I be thinking here? 30, 60, 90, 45, 45, 90, does they have any zeros on them? So what's my other option here? Yeah, the unit circle. So we're looking for sine is the y value, isn't it? So who has a y value of 0? It would mean that it's sitting on the x-axis, wouldn't it? Wouldn't it be these two angles? So I actually have two here. If you think about it, this is the point, -1, 0. There's the y that's 0. Over here we have 1, 0. There's the y that's 0. So we're either talking about x is equal to 0, or it could be pi. And if I wanted to represent all of those values, they didn't ask me to here. If I wanted to represent all those values, I could say, well, it's 0 plus a trip around the unit circle would be 2 pi times n. That way I can go forward or backwards, except that 0 plus 2 pi n is really just 2 pi n, isn't it? So if I wanted to write all the values, if they only want one trip around the unit circle, 0 and pi are my solutions. If they want all values, so if I'm writing all these solutions, I could say, if I were asked for all the solutions that would have that sign, it would just be 0 plus 2 pi n, and that simplifies to 2 pi n. Or it could be, let's see, pi was the other one, and I could keep going in circles around the unit circle to get to pi, so it would be pi plus 2 pi n. Ooh, that didn't come out the way I meant for it to, plus 2 pi n. Okay. So, so that would be the other one. So if I were listing all the solutions, which it doesn't ask me to do, I'm just kind of doing this because we're going to be doing this a lot soon, and I just want us to kind of think about it as we go instead of, all at once kind of hitting us. Okay, so here's one from your homework, number 5, and this is an example of one where you're going to have to think a little bit about how they got the fraction. I'll just do the A part, just as one more example. They say arctan square root of 3 over 3, and they tell us to find the angle without using a calculator. Okay, so again, this is the same thing. You might sometimes see it written this way. Now, there are no 3's in 45, 45, 90s, correct? They're all 2's and square root of 2's. Okay, so if we saw 2's and square root of 2's, we would think 45, 45, 90. In the unit circle, it's all 0's, 1's, and -1's, right? So I'm not going to go there. I'm going to go to the 30, 60, 90, okay, because I do know that there's a square root of 3 there. But where did this 3 on the bottom come from? If I label this x square root of 3, there's a 2x on the hypotenuse. Right, so we kind of have to backward think here a little bit. To get the square root of 3 over 3, didn't we have this, and then we rationalized it? Do I have y'all's attention? I just don't feel like I have anybody but Katie's attention. Do I have everybody's attention? Because this is not, logical. I mean, it is, but not something you look at and go, oh, yeah! Okay, so it started out being this, and we rationalized it, and we got square root of 3 over 3, right? So really, when I look at this circle, when I look at this triangle, I don't know my shapes now, I'm looking for tangent is opposite. If I'm thinking about SOHCAHTOA, tangent is opposite over adjacent. And I want the angle where the side opposite was 1 and the side adjacent to it was square root of 3. What would it be? 30 degrees. If you look at 30, opposite would be x, and adjacent would be x squared root of 3. I could put 1x out front because that's how many there are, and when I canceled it out, I would get that 1 square root of 3. So when you see something and it looks confusing, think about what triangle has those numbers and the coefficients, or is it 0's and 1's? So that'll help you determine where to go. And then think about, okay, has that been rationalized? Because if not, you're going to, it gets really confusing. So you've got to kind of think a little bit about how that value came about. And if it's not one you're used to seeing, think about has it been rationalized, okay? So that's a big thing to watch for here. Okay, what they're wanting you to do is write theta as a function of x on this one. So what trig function could I use to find theta here? I have the opposite side, of that angle, and I have the hypotenuse of that angle. And think about SOHCAHTOA. Which trig function should I use here to find the angle?
Sine.
It's a sine, and I'm trying to find the angle, so it will be sine to the -1. That inverse sine, right? Which looks like sine to the -1 power, but isn't. And then I'll put in my opposite is x plus 2 over my hypotenuse, which is 5. So they're just wanting you to write something like that down. Use the sides they labeled.
That's it.
That's it on that one. Find the length of the third side of the triangle in terms of x, then find theta in terms of x for all three inverse trig functions from the recorder on down. So the missing thing is the hypotenuse. So the hypotenuse squared, we're going to write it in terms of x here, is 2 squared plus x plus 1 squared. Let's simplify that. That's going to be 4 plus, now I have to remember, x plus 1 squared is not x squared plus 1, is it? It's x plus 1 times x plus 1. Everybody realize that, okay? Because this messes so many people up every time they take a test on this stuff. So if I multiply that out, it would be what? X squared plus 2x plus 1. If you need to, write that all out and distribute to get it, you can. I'm just going to assume that you could put that step in if you needed to. Hopefully you're getting to where you can kind of do some of that in your head. If I simplify that, c squared is going to be x squared plus 2x plus 5, because at least I can add those numbers together. And then if I want to know what the side is, what do I have to do to finish this up? Yeah, I don't want to know c squared. I want to know c, so I'm going to square root it, okay? So this side would be the square root of x squared plus 2x plus 5. And if I wanted to find the trig functions, I'm still going to just represent opposite over hypotenuse, or adjacent over hypotenuse, or opposite over adjacent. But I'm going to use this red term here to represent c so that it's all in terms of x. I'm not going to have a number. I'm just going to have a icky-looking expression. Should you rationalize the denominator if you have that on the bottom? Yes. Okay. Same sort of thing. It's just going to have a bunch of x's in it. So we'll see how that goes. And if you have questions, remember to check your work in the back if you're not doing that so that you know whether you've gotten something wrong or not.